Lesson 221, Composing Integers. Today's daily learning target is, by the end of the period, the students will compose and decompose numbers in multiple ways. Compose means to build up, decompose means to break down. So your in-class video will cover questions 31 to 34, and your homework will be questions 36 to 41. In class 231 to 234. Lesson 221, Composing Integers. Let's see if it's not on me. Okay. Question 31, Crossing the tightrope. Cecil is an acrobat in a local circus. His job is to move across a tightrope from point A to point B while blindfolded. He can only move using the distances you tell him to move in your instructions. He needs to reach the end of the tightrope, which is right here, okay, point B, to take his bow and go down a ladder. Assume the platforms on both sides of the tightrope extend indefinitely and have no end. Cecil may have to go past the ladder. However, if he does, make sure he turns around and goes back towards the ladder. So if he goes past this B, like he ends up over here, you've got to make him turn around and go back. Okay, your task. Work with your team to find different combinations of lengths given in parts A through E below that will allow Cecil to move from point A and end at point B at the end of the tightrope. You may use each length as many times as you like. For each crossing, look for at least 3 different ways to get the acrobat across. For each solution, draw a diagram on your paper to show how the available lengths were combined. Alright, so Cecil has to get Cecil has to get across so the tightrope is 24 feet long. We are only allowed to use these numbers and their opposites. So you can use 2, a -2, a +4, a -4, a +8, a -8, a 10, or a -10. Any combinations of those numbers to make 24. And you may use any of these numbers more than once. So the first one to get 24, 10 plus 10 plus 4, because that makes 24. Anything else? Oh, very nice. 8 plus 8 plus 8. Okay. Anything else? Let's try to use a negative. How about 10 plus 10, that's 20. So if that's 28, he needs to go back how many? 4. So this is how you say he goes back 4. Good job. All right. Now the tightrope, it's a lot shorter. It's 17 feet. We are allowed to use these 3 numbers and their opposites. So how do you make 17? How about 10 plus 10 plus a -3. I'm putting parentheses around my negative number so that the plus sign isn't right next to a negative number. Okay, anything else? 10 plus 3 plus 3 plus 3, that's 19, and so he has to go back 2. Okay, how about 3 times 5 is 15 plus 2. 3, 2, 3, 4, 5. Because 3 times 5 is 15 plus 2 more. Awesome. Okay, so now the tightrope is 15 feet long, and those are the numbers we're allowed to use. Oh yeah, I see it. 4 plus 11, that's 15. What else makes 15? 3 plus 3 plus 3 plus 6. What else makes 15? How about 11 plus 11? That's 22. And then he has to go back 7. So then to go back 7, first we'll go back 4, and then we'll go back 3. That's a 3. nice. Cool. Go to the next side. Oh, there's a lot of these. Okay, no biggie. So now, what's going on with this? So now the tightrope now the tightrope is 27 feet. Oh, we're allowed to use these 4 numbers, well really 8 numbers, because these 4 positives and their opposites. How do we make 27? 19 and 8. I don't have it. Oh, but I have an 8. Nice. What if I break up the 8 with a 4 and a 4? Okay. What if I made the 8 by doing 12 plus a negative 4? So now the distance is 23. Kind of hard. I know. Let's do 13 plus 13 plus 11 plus negative 7 plus another negative 7. Let me do this to the side. 13 is 26 and 11 is 37 minus 14. 23. I just want to check. Alright. The next two. So I have 7 sevens, which make what? 49? So how do I go from 49 to 23? I have to get rid of 26, so let's subtract 13 and 13. Okay, and if you want the answer to this one, you need to watch the video. Oh, we're doing the video now. I need to do it. Mer. 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 11 is 88. If I want to get to 23, I have to get rid of 65. So then we'll get rid of 65 by 5 negative 13s. Last year when I did that one in class, kids got stuck on that one. Alright. To represent the way that the acrobat could move across a span of 17 feet. What is it? So click it to me. Okay, just get over it. Okay. To represent the way that the acrobat could move across a span of 17 feet, Mara wrote expressions shown below. If each number represents a length in feet, check that each expression would get Cecil exactly to point B. Okay. So how much is this? 17. 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 Alright. What does the negative 3 right here in part D represent as a movement to Cecil? Negative 3 means move write numerical expressions similar to those in problem 32. Oh, and we want to get to 15 feet. And this time it says use any length you want. 5 plus 10. 10 plus 5. 7 plus 3 plus 5. 10 plus 10 plus negative 5. That looks blurry. Me? Oh my gosh, it was blurry. Why is it blurry? Alright. When combining lengths, to make a new length like you did to get the acrobat across the rope, does the order of the numbers or lengths matter? No. Because look, I put 5 plus 10 and over here I put 10 plus 5. So the order doesn't matter. Okay, discuss this with your team or partner and decide whether it matters or not. Okay. Addition is commutative. That means the numbers can move around. The order does capitalize not matter. Awesome. And that's the end of that one. That was a quick one, eh? Alright. Your homework is questions 36 to 41 in chapter 2. Bye.